Good afternoon, my dear class 10 students of ICSE board. I, Arun Kumar, have come in front of you to make you a easier way in chemistry. So the examinations are knocking at the door, and you might have well prepared with all the subjects, and one of the subjects is chemistry, in which the very first chapter is periodic table. My dear students, first let me know that in class 10 ICC board you have 9 to 12 marks, and today I'll let you know how to get 12 out of 12, that is 12 out of 12 in ICC board just within 6 minutes spending in examination hall. So why to fear? मैं हूँ आपके हर मुश्किल को आसान करने के लिए इस केमिस्ट्री फर्स्ट चैप्टर पर। तो चलते हैं। पहला चैप्टर जो आपका बनता है वो है पीरियोडिक टेबल। आप लोगों ने क्लास 9 में भी पढ़ा है पीरियोडिक टेबल के बारे में। अच्छे अच्छे साइंटिस्ट आए हुए थे, पहले वे एटॉमिक मास पर बता रहे थे, फिर धीरे धीरे एटॉमिक नंबर पर हम स्विच ऑन कर गए। अब जो कुछ भी है इस पीरियोडिक टेबल से हम आपको ये बताना चाहते हैं कि जो 12 मार्क्स का क्वेश्चन आता है जस्ट 6 मिनट में आप कर सकते हो इन एग्जामिनेशन हॉल पे। ध्यान से सुनिए, भगवान ने आपको हर पोटेंशियल दिया हुआ है, बस उसका ही इस्तेमाल करिए ध्यान से। तो बचपन से लेकर हम आज तक बहुत कुछ सीख चुके हैं। पहला है कि इस चैप्टर को सीखने के लिए हमें कक्षा 3वीं या 4वीं या 5वीं का ही उसका कॉन्सेप्ट लेना है। किस चीज का कॉन्सेप्ट लेना है? हमको पता है कि जब कोई चीज ज्यादा दूर हो जाती है तब उनका आकर्षण भी कम होने लगता है। एंड वी हैव रेड इन class 6 and 7 Newton has said, a lot of scientists have said, even Kepler said, the more is the force of attraction or repulsion, whatever it may be, whatever the forces may be, it is inversely proportional to the square of the distance between the two objects. The same concept we are going to use here. So more is the atomic radius, that means lesser energy is required either to take electrons to its valence shell or to take out the electrons from its valence shell. So whatever the periodic properties are there in your syllabus right now in class 10 ICC board is completely based on atomic radii. The very first definition of atomic radii we are going to learn is, what is atomic radii? It is the distance between the nucleus and the last valence shell. Let me draw one diagram here. Suppose this is the nucleus of an atom and this is the first shell, this is the second shell. Suppose this is the last shell. So the distance from here to this last shell is said to be atomic radii. It is atomic radii. So this thing you have to keep in your mind. One more thing, atomic radii is measured in angstrom. That is like this, we can write it here. Number 2 is atomic radii is measured in angstrom, and also we know that this distance is said to be bond length. My dear, I think you might have understood these 3 things right now. Next, we go to the next topic is in periodic table. We have learned that from left to right, if we move, it is said to be a period, and down the period and downward if we move, we say it as a group. So periodic table has from left to right it is period, and down we say it is in column wise, we say it is group. These are the periods, horizontal rows are periods and verticals columns are called groups. Now we have to get only this concept perfectly and correctly. Let us take an atom of atomic number, suppose 18. So if the electronic configuration of 18 will be what it is, first 2, 8, 18. Next let us consider 17, it is 2, 8, 7. 16 we consider as 2, 8, 6. So K, L, M. This is a K shell, L shell, M shell. Now you can see that 16, 17, 18. You see that here the number of shells are 3. Here the number of shell is 3. Clear? Here also number of shell is 3. Here also number of shell is 3. That means from this we can understand that the number of shells represents number of period. That means all this lie in third period. Next, in the last shell you can see here 8 is in the last shell, it has completed octet, it has 8 electrons. Here we have 7 electrons, here we have 6 electrons. So these are said to be valency electrons. So number of electrons present in the last shell are said to be valency electrons. See here, we are in your syllabus, you have 1, 2, 3, that is 1, all the A group you have in your syllabus. Here the valency electrons is 6, so it is in the 6th group. Here the valency electron is 7, so it is the 7th group. So the number of valency electron represents the number of group A. Let us consider one more. Suppose let us take sodium. Let us take sodium. The atomic number of sodium is 11, so it is 2, 8, 1. That means here the number of shells are 3. It lies in the third period. The valency electron, this is valency electron 1, so it lies in third period, first group. Now, and the valency is 1 here because it is very easy to take out one electron from this and to form the nearest and to form an octet and to attain the nearest noble. So now we come here, we go with one more example from that. Let us take potassium, or here also the number of shell is 3. It lies in the third period, and the valence electron is 2, so it lies in the second group. Also we have learned regarding sodium, that is 2, 8, 1. That is, here also number of shell is 3, that means lies in the third period, group 1. Now what is the difference between these two? They have the number of valence, number of shells are 3. Let us see here. So suppose it is here, I am representing sodium here. So in the last shell for sodium is, here are 2 electrons, here are 8 electrons, in the last shell is 1 electron. The atomic radius here is from here to here. Again for magnesium, the last shell number of electrons are 2. Now see here both are But here in this, the nuclear charge is greater than the nuclear charge in sodium. So what happens here? It is number of electrons are more here than this. That means in this case there is more force of electron, more force of attraction is there between the nucleus from nucleus to last shell, and here also the force of attraction is lesser than this because the number of the nucleus charge is less than magnesium. That means what? Here the force of attraction is much more than this, although the number of shells is same, but here due to the more attractive force the atomic radii will become less. So the atomic radii of magnesium is lesser than the atomic radii of sodium. That means what we have understood from this? We have understood from this is that more from left to right the atomic radius gets reduced. That means what? Why atomic radius gets reduced? Because the nuclear charge gets increases. That means more the nuclear charge, atomic radii is less. That is more force of attraction occurs from left to charge. That means from left to right the nuclear charge increases. Okay, number of shells remaining the same and atomic radii gets decreases. So, and while if we go from top to bottom, we can see that it is quite opposite. Whatever we are achieving from left to right, it will be the opposite of that. That means from top to bottom the atomic radii gets increases, though nuclear charge also increases. But you have to understand, since the atomic radii overcomes the nuclear charge, so if from left to side if it is increasing, then from top to bottom it will decrease. It will be the opposite of whatever occurring in the periodic table from left to right across the period. So now with this concept of atomic radii, we go with the different periodic properties in this chapter. Till now you have understood regarding atomic radii, everything revolves along the atomic radii. Now we are going to read out the periodic properties in your chapter, whatever it is given here. Try to understand it very clearly. If you have any doubt, you can raise your fingers in your comment box and comment it. The very first periodic property is that we often have seen that sometimes the atom either they lose electron or they gain electron. While losing electron or while gaining electron, energy is required, either energy is required or energy is released. So the very first term is ionization potential, that is IP. The ionization potential is measured in electron volt, EV, already you have learned in physics. Now, what is ionization potential? It is the amount of energy required to remove an electron from its outermost shell of a isolated gaseous atom. And also one more term is there. Suppose the gaseous atom wants to accept, then the amount of energy released to accept an electron to its outermost shell. So this is what we say as electron affinity. And here also it is measured in EV, but don't forget, here the symbol should be negative. One more thing is that we also know that sometimes in valence electrons, so valence electron in the last shell, valence shell, we have free electrons. So either the electrons are taken out. So when the electrons are released, that means what? If we say that we can consider regarding the metallic properties, then what we can say from the metallic properties, I'll put it the definitions on your board. Non-metallic properties, how they proceed with the atomic radii. The very first concept is that regarding IP, when we go from left to right, what we have understood along the period, we know that having the number of valence shell same, but atomic radii gets decreases. So once the atomic radius get decreases, it becomes tough. That means we require more energy. That means the IP increases. So from left to right along the period, IP gets increases. So if from left to right, if it is along the period it increases, I already said you, then down the group, okay, down the group it will decrease. So in this way we can find out all the properties. So the very first property is ionization potential. I am going to write down the definition over here, and all the definition with how they are changing I am going to make you understand. The very first one is ionization potential. Already I have said to you, that is the amount of energy required to remove an electron from the outermost shell of a neutral isolated gaseous atom. We can represent it as, suppose this is atom. What we are doing? We are taking out electron and we are getting this. Now we know that from left to right, atomic radii increases, atomic radii decreases. Since the atomic radius decreases, more is the force of attraction. That means more energy is required. That means ionization potential increases. Ionization potential increases. And down the bottom, ionization potential decreases. This is the number one periodic property. Number two periodic property, again we know that it was electron affinity. And by the definition it was written that amount of energy released to accept an electron from in the outermost shell of any isolated gaseous atom. So in that case also the atomic radius gets decreases from left to right. That means what? More is the force of attraction because nuclear charge is more. So hence the EA, that is electron affinity, which is taken as negative EV, increases from left to right and simultaneously decreases from top to bottom. That means both ionization potential and electron affinity, it increases from left to right across the period and decreases down the group. Next we go with another topic,